so that you have access to it if you missed something. But this is your week 7 packet. It's a research summary, so these are all going to be about experiments. That does not mean they're all SIN, but it does mean that they're all about experiments. So what's the first step? Yeah, go to the questions. So, which of the following statements explains why the students varied the mass? What does that mean? Yeah, so that's a change of the weight atop the wooden block in experiment 1. What's my locator? Right. So the students wanted to. I'm not going to read my answer choices first. I'm going to just go to the experiment. So I'm going to find experiment 1, which I have down here. Experiment 1. Students placed a wooden block with a surface area of 100 centimeters squared in the apparatus depicted above. A tangential force was applied, and the force at which the block began to slip was recorded in newtons. The experiment was repeated using weights of differing masses atop the block. The forces required to cause the wooden block to slip. So what were they measuring? What's their dependent variable? The what? Dependent variable. What were they recording? Nope. The force required to cause the block to slip. That's your dependent variable. And the mass is your what? They changed it, so what is it? Independent variable. So tangential force is what they compared it to, Peyton, but it was the mass of the block. Okay, so now we can go back to our answer choices. Measure the amount of downward force. Did they mention downward force? No, the force they compare it to is what kind of force? So it said tangential, although it slipped. We'll look at the apparatus in a second. So measure the amount of downward force between the wooden block and the plane. Vary the amount of tangential force. So what does this say right here? So our answer choice should have what word in it? So that means we're going to be between B and D. So I'm going to cross off A and C. Now this says vary the amount of tangential force on the wooden block. And this is vary the downward force between the wooden block and the plane. So, pardon? So let's look at here if it has all the parts of the apparatus though. Right, so this says a tangential force was applied and the force at which the block began to slip was recorded. So that means that it was the mass and the block slipping. So we're here, vary the amount of tangential force on the block, vary the downward force between the wooden block and the plane. Yeah, Kayla, you're right. So this one would be B. Okay, this pen sucks. Alright, number 2. In experiment 1, what am I locating? What's my locator? Experiment 1, students varied which of the following factors? So what did we change in experiment 1? Yeah, the mass on top of the wooden block. The answer is G. We didn't even have to think about that one. Alright, number 3. How is the design of experiment 2 different from experiment 1? So experiment 1, they had the block, and they changed the mass. Now we need to figure out experiment 2. So I'm going to flip to experiment 2. So experiment 1 was repeated using the block of the same mass, but a surface area of 200 centimeters. Okay, so what did they do? What did they change? Yeah, they increased the surface area. What's the surface area in experiment 1? What's the surface area in experiment 2? So the surface area of the block is twice as large in experiment 1 as experiment 2 as it is in experiment 1. Right, so it's 200 versus 100. If even before flipping to that, do you see how A and B are almost the same? So I can cross off C and D. They're just opposites. So the answer to number 3 is A. Alright, number 4 says, if experiment 2, so that's my locator, is continued using a 3 kilogram mass, the tangential force required would be approximately. So this is one of those interpolate, extrapolate questions. So I want to use a 3 kilogram mass. So I'm going to go to where? What's my locator? Experiment 2. So as this increases, now where would 3 fall? 3 would fall right here. That's what question 4 is asking. What does the tangential force do? Increases. So we want to know what this would be. So I know it's going to be greater than 30.6. How much does it increase by each time? 6. So this is going to be around what? 36-ish. And then we're going to go to the answer choices that Kyla already read for us, and that is 36.8. Questions on any of those so far? Okay, number 5. Several students were asked to push a box to the other end of their classroom. Please don't do that in here. We've ruined enough. I'm going to be shady about that literally for the rest of the year. Alright, I'll tell you about it later. Based on the results of their experiments, how could the students minimize the force necessary to push the box? The students could. So, we want to minimize the amount of force necessary to push the box. This one we actually probably have to go to all the experiments and review. So, what did we do here to have the smallest force for pushing the box? What did we do here to get the smallest force in experiment 1? Yeah. So this one, smallest mass. We minimized it in experiment 1 by putting the smallest mass. Now in experiment 2 are the forces are actually almost exactly the same. So in experiment 2, to minimize it, we used a smaller mass again. Then experiment 3, it said, in this experiment, the coefficient of friction between the block and the plane was lowered by applying grease to the plane. The procedures were repeated. The forces required are here. Is the force here higher or lower than in experiment 1 and 2? Lower. So here we did a big minimize, and what did we do? Yeah, so we did grease, and grease did what? Grease lowered the what? Nope. Yeah, friction. So let's see if we have an answer choice that matches that. So rotate the box. No, we don't talk about that at all. Decrease the coefficient of friction with grease. That one sounds pretty good. Pull the box, don't talk about that. Increase the mass is the exact opposite, so our answer is B. Questions on 5? Yes or no? No. Okay. 6. Which of the following factors was not directly controlled in experiment 3? So, what's my locator? So, what did we directly controlled as an independent or a dependent variable? So the thing that the scientists are in charge of is independent, and then also your controls here. So what did we do? What did we directly control? So we directly controlled the mass. We directly controlled the grease. So we greased it. We took the mass. What did we not control? The force. And then it says the procedures in experiment 1 were repeated, so I'm going to check experiment 1 just to see if we missed anything. So 100 centimeters squared, that's another thing we controlled, right? Because that's something that they kept the same, so 100 centimeters squared. So, let's figure that out. The tangential force required to the wooden block, did we control that or no? We did not control that, that might be an answer. The mass, did we control that? Yep. The coefficient of friction, did we control that? Yeah, we put grease on there, so we reduced the friction. The surface area, did we control that? Yeah, everyone was 100 centimeters squared. The answer is F. Alright, our last one, number 7. If experiment 3, that's my locator. Will not focus today. Was repeated using a wooden block of the same mass, but a larger surface area, how would the tangential force required be affected? Okay, so this one is probably the trickiest one. So in what experiments did we change the surface area? Experiment 2. So I'm going to look to see what pattern we have. In experiment 2, let's look at these tangential forces on a larger surface area. Now, good Kyla, let's compare this to experiment 1. What are the forces again? The same. So if we change the surface area, what happened? Nothing. So what do we think our answer is going to be on this one? Why? Yeah, nothing happened when we did that in experiment 2. Just so many scientists over here. Alright, questions? Beautiful.